Data quality is about more than just fixing issues with your data. It's about maintaining good data quality over time, which first requires a baseline understanding of what good data looks like and how your data compares. The Data Integrity Suite lets you do all of this in a way that is easy to use and understand without sacrificing technical functionality. Once you connect to your data, it appears in a catalog where you can view your data sources, data sets, or fields. From the catalog, you can use the metadata across the suite. You can click to view the details of this data source, where you can then see all the schemas, data sets, and fields related to that connection. And you can drill down to view more details on one of the tables. Notably, you see the data quality score that was calculated during the harvesting of the metadata, both at the field level and aggregated at the table level, alongside the data governance score, which is monitoring how the metadata of the asset is treated and governed. Let's focus on the profiling. Right away, you get a sense of what your data looks like and where we might have issues. The first thing you see is an overview on the table. Statistical information like the null counts, blank counts, minimum maximum values, as well as the distinct values and the data type. During profiling, we automatically detect the semantic type based on the content of the data. When you click on a line, you see the information panel on the right-hand side with all the details of the profiling as well as a confidence type. So how confident are we that this is the right semantic type? You can drill down into the details on the full screen view. If you click into one of these statistics, it shows the trend of these profiling metrics over time. You can zoom in and out on the timeline using either the drop-down menu or the slider at the bottom. Data observability takes this even further by detecting anomalies, outliers, and drifts over time using AI and machine learning. Here we detect 4 different elements. Has the overall volume of the table changed? Has the data itself changed notably? Has the schema changed? Or is the data no longer fresh? We observe your data over time at intervals that works best for you. We learn how your data typically changes over time and alert you of anomalies that fall outside of those typical types of change. For you, this means proactive alerts when something unexpected happens to your data before it becomes a problem downstream. Beyond standard profiling, you may want to apply quality rules around your data to encode important business logic that constitute good quality data. You may be a business user who knows your data and business domain better than anyone. Now the Data Integrity Suite lets you take control of your data by describing what you need to do with your data in conversational terms without needing specific technical expertise to craft and enforce data quality rules. You will see we have some default quality rules, for example, pre-built rules that check all fields for blanks or null values that can be applied to all assets in your data catalog. We also have a default validity check that provides an out-of-the-box rule based on the field semantic type. You can create a custom rule on a specific field on a dataset, which allows you to leverage multiple fields in your rule, or on fields matching a condition. For example, if you target a semantic type, we automatically apply data quality rules that meet the criteria. You have the option to filter the data based on either a basic condition, which could be just is empty, is null, etc. You can also use advanced matching capabilities to build a row filter or simply specify it in plain language using AI Assist. The same is true for the rule itself. In this case, I will use AI Assist to create the actual rule logic using plain language. For example, what you would like to check is if the size field ends with ML or L. Now we have our past condition that was generated using plain language, but how do we know this expression is correct and does what we intended? You can click Test with AI generated data to validate the rule logic. It will generate several synthetic values, which you can scan through and verify whether the rule logic is passing or failing them as expected. Now you, as a business user, can have confidence that the rule we just created using plain language works as we expected on a varied set of data. Next, you can give your rule a name and tag the dimension the score will roll up into. Then you can also either type in the description or have AI assist generate a description that matches your actual validation logic. If you want, you could retry the AI generation, tweak, or add context to the description as you see fit. That's all you need to create a data quality rule without the need for specific technical skills, as we can generate the rule with plain language, test it automatically to validate the approach, then get back a plain language description of exactly what the rule expression is doing. The rules can be triggered manually on a set schedule or via an API. Once a rule has been created and executed, you have the ability to see the details of that rule. How many records have been processed, how many records may have been filtered, how many records passed, and how many records failed. By clicking on the failed records, you can see an overview of the failed records for this rule. Fields that are being used are highlighted in red. So in my case, I can now see all the records that do not pass the rule and swiftly determine what caused each record to fail this check. Rules can also be reused within the data quality pipeline to identify records for transformation. In addition to data quality rules, we provide the ability to create data governance rules. Data governance rules are set up the same way. The difference is that they monitor the metadata for the dataset and evaluate the metadata compared with your data governance criteria instead of evaluating the quality of the data itself. Now you have a deeper understanding of your data through profiling, observability over time, and even custom quality rules. With these ongoing measures in place, let's go ahead and improve your data. Data transformation can be done using a wide variety of out-of-the-box steps you can easily drag and drop into your data quality pipeline. From foundational steps like filtering, splitting, and parsing, to flexible custom coding rules. Not to mention we can evaluate rules leveraging any of the data quality rules we have previously built. When opening a data quality pipeline, you see the pipeline steps at the top and the data you work with at the bottom. We provide profiling information in order to help you setting up the different steps, as well as machine learning-based suggestions that recommend next steps based on active metadata. Notably, we provide the ability to verify addresses, geocode addresses, and then enrich those addresses with various informations, leveraging a unique ID for every address called the Precisely ID, and tapping into Precisely's vast knowledge and expertise in location and risk data to augment and standardize your data. This ID allows you to easily enrich the data even further with additional data that we provide like demographics, risk, point of interest, and a lot of other information. Once you have completed your pipeline, we provide flexible delivery options, including batch processing or deploying data quality as a service. If you choose the batch deployment option and the data source is, for example, Databricks, Snowflake's BigQuery, or a similar cloud data source, the pipeline is being processed where the data resides. For on-premise data sources, the pipeline also runs where your data resides via the execution agent. When deploying as a real-time service, you can then use it with different endpoints to call that process from within your application. Now that you have ensured high-quality data by standardizing, verifying, and enriching in your pipeline, you are prepared to tackle matching and merging related records. We provide 3 different ways to configure matching and grouping. The first is entity-based matching, allowing you to match records based on entities you specify, for example, name, location, or contact information like phone and email. Automated matching uses artificial intelligence and machine learning to match and group records based on name and location of people or businesses. As well as a customized matching where you can use even different levels, different fields, different scoring, different routines. A very configurable way to do the matching. These methods are also in addition to being able to conduct complex data joins, inner, outer, etc., and unions. Matching records are automatically color-coded, grouped in the same data table and given a unique group ID. The system identifies duplicates, suspects, and unique records for the user's review. Once you have matched your records, you can consolidate the records. We also allow you to specify the desired approach for consolidation. One option is best of breed, which consolidates records by retaining the highest quality entry as a single source of truth. Or you can use Commonize, which offers multi-level consolidation rules to standardize and copy the data across all records within the same match group. These strategies leverage precisely best-in-class IP from our Spectrum and Trillium products, now integrated into the Data Integrity Suite right where you need them to effectively handle, duplicate, and consolidate your data. How can you know when your data quality drops? When an observer identifies an anomaly, it sends out an alert, and users can subscribe to receive an email notification for these alerts. Remember that observability continuously observes metadata and learns from your data over time using AI and machine learning. So you are alerted on anomalies of volume, data drift, schema drift, and data freshness automatically. In addition to an aggregated alert dashboard, you can drill into a specific observer and quickly visualize a summary of observation alerts as well as details on each alert to better understand the potential issues that has been flagged. You can then take any remediation step necessary and close the alerts to remove the notifications. You can also configure a more advanced workflow to notify yourself or a group of people on changes to your data. This includes a task list as well as email notification. Workflows create data quality score alerts when a percentage drops or changes, as well as assignments for these responsible users to take actions. When you click into an assignment, you can see which step we are on in the workflow, as well as complete the form task that has been assigned to you. This is where users can provide input to these workflows, whether by simply approving a request, answering a question, or filling out additional form fields, allowing for proactive remediation and other automated workflows with humans in the loop. Workflows can be created to notify users of a variety of events, including a change in the quality score of data for which they are responsible. Configuring a workflow does not require any coding skills. You simply drag and drop the different activities to the visual workflow editor and connect the boxes. Workflows can be triggered either based on an event, such as an item being added or changed, or on a set schedule. For example, you might want to notify certain users when a quality score drops, or when someone requests access to a dataset. As activities, we provide email, form, field change, relationship change, API call, and deleting content. With an activity, you may configure an email notification using template language and passing in variables depending on metadata information from the catalog. For example, dynamically inserting the workflow initiator's name. You can also configure a form requiring additional fields to be filled out during the workflow process. You can assign users, groups, or personas to respond to this workflow step. If you want to call third-party tools, we do provide the activity to make an API call. In this case, it is a Jira call that has been made to open a Jira ticket. Once the ticket is completed on the Jira side, we can also wait for the response, which is then sent back to us to complete it within our workflow process. As you can see, if you have an external resolution system, you can connect to it and send and receive data in your workflow. Alternatively, you can use our issue resolution capabilities. Issues are routed to queue for resolutions. User or a group of users can be assigned to work issues in a queue. Users are notified via workflow and on their task list that they have an issue to work. Related issues can be automatically grouped together into cases that expedite resolution. Supervisors can view a dashboard like this to see the cases assigned across their team. Configurable dashboards are created to tailor towards the user persona. With appropriate permissions, user can assign bulk update edit issues, or escalate them to help drive resolution faster. The flow of issues is configurable and can require approvals. Logic can be set up to recommend a possible resolution. The final disposition can be entered or selected by the user who is working the issue. For each workflow, we also do provide additional information like a version history, where you can see what has changed, how much has changed, and which persona has made those changes. The Data Integrity Suite has the ability to connect to around 200 source systems. Remember that after you connect it to your data once, it appears in the catalog and your metadata is available across the suite. We will allow you to import technical and business assets from third-party tools in configuration. When you look at your datasets details, you see various metadata surfaced here, including critical data elements and PII designations. Having discovered a quality issue on one of your fields, you want to analyze the root cause and mitigate downstream risks. Fortunately, data lineage is automatically available for data sources, datasets, and fields. You will drill down into a dataset to look at the lineage diagram. On the lineage diagram, you can then search for a specific field. You may want to filter based on the dataset itself, or you can filter on the data quality score. You are filtering for a low data quality score, so you can home in on the areas that need improvement. You see also how the data is being used or processed throughout your organization, which is automatically generated by just cataloging the different datasets. Clicking on a field shows you the flow and usage of that field across the different data sources. You can see that the zip code was quite low, and it got improved because of a data quality pipeline process. You can also see that the zip code is being used in two different Tableau reports. On the right-hand side, you always get the detailed information on the asset itself, as well as profiling summary to bring in that context here for further insights. In case the data lineage is not being generated automatically, you can link the different fields or tables manually by toggling on the edit mode at the top right. Now you can add upstream or downstream lineage either to a dataset or a field. You can select these from the catalog on the right-hand side, where you can also search to quickly find what you are looking to add to your lineage. Now you can easily see how quality evolves throughout the life of your data and home in on points of change while knowing exactly where your data is being used. Unstructured data can be easily processed within a data quality pipeline, and this process is even more accessible to all users thanks to AI assistants embedded in these workflows. In this example, you have a field that includes various informations within a textual description. You can use an LLM transform step where you can use natural language to describe the transformation. The LLM transform step integrates the customer-selected large language model into the pipeline. This step is inserted in the pipeline and takes the requested action. All data available at that step can be used in the pipeline. Simply specify the input and output fields and enter the instruction in natural language. In this case, you can just tell it to parse the input into these fields. You can preview this transformation step and verify it separates the input data as expected into the different columns. This LLM transform step can also be used to identify sentiment analysis of a semi-structured data fields like comment, review, or feedback text fields. Another example might be if you have data in a JSON format as an input field. Again, you can use the LLM transform step within a data quality pipeline by defining the input and output fields and saying what you would like to do with it. In this case, street, city, zip code, and the name are now separated fields extracted from the JSON. And from there now you can continue with the data quality pipeline process. For example, enrich and verify the data, geocode it, and maybe even if needed, deduplicate and consolidate the data. We also have a pipeline step that allows you to leverage JavaScript code for custom logic in data transformations. That can also be helpful with unstructured data. And now, with AI Assist, you can generate this code using plain language. enabling non-technical users to take advantage of this flexibility and customization. Just like LLM Transform, we can prompt the assistant and in this case generate code that we can then review and tweak as necessary. Here you can see in the step preview that the coding step has updated all the appropriate values so that all of the fields in the new columns are standardized.